My name is Alon. I'm the CEO of a company called Blocks, and we develop SSV, which stands for Secret Shared Validator. I wanted to share with you because I truly think it's one of the more interesting things I've got a chance to work on. I kind of wanted to spread the word and see if it's relevant for any of you. So, Secret Shared Validator, let's see if the clicker works. Okay, perfect. So Secret Shared Validator stands for, SSV stands for Secret Shared Validator. It's a technology we've been working on the past, I would say, more than 12 months. And it has the goal, or at least the objective, to really redefine Ethereum staking infrastructure. And you'll see in a second why. It will enable anyone who's running an Ethereum validator to do so in a decentralized way. And it seems counterintuitive because Ethereum is decentralized, but the infrastructure itself is pretty centralized, or at least tends to be very, very centralized. And it's aimed for really anyone who's running a 32ETH validator, so stakers, DIY stakers, staking pools, institutional stakers, and so on and so forth. And it uses two pretty well-tested components, which are threshold signatures and a BFT protocol, a consensus protocol. So why it's really important? There's a lot of things happening in Ethereum too. Why is this particular thing important, and what are the ramifications if we don't do something about it? So Ethereum staking in particular was really conceived with the scope of having one validator equal one vote. And specifically, that's coupled with the fact that the protocol itself tried to really hard to reduce economies of scale, which are really the kind of the description of the legacy proof of work consensus protocols, where the more power you have, the better performance you have in the network. When in Ethereum staking, at least the scope was to really reduce that as much as possible to avoid centralization and, of course, incentivize decentralization. And that's really important because if the clicker works. That's really important because if we kind of going forward and looking at the future landscape, currently we have about 6.4 million ETH at stake, which is pretty significant. But as we fast approaching the merge, we'll see higher rewards, and of course that will push more and more deposits into the staking protocol, and of course it raises up a lot of innovation in terms of the staking services we'll see. More and more staking services will come online and offer different quote-unquote flavors of staking. And of course, there's other concepts or other challenges which are just starting to emerge, like MEV, which has very particular challenges in proof-of-stake ecosystems. And all of that really creates a lot of challenges, one of which I think is really, really important, is in terms of the infrastructure that stakers using, staking services are using, and so on. Most of the infrastructure today is really defined or really influenced by the slashing conditions we can find on Ethereum. Those conditions in which if you violate them, you get pretty severely penalized and you get ejected from the protocol itself. And of course, when withdrawals are not enabled, those two things combined are pretty important. And so the infrastructure today is very much influenced by those conditions, which in a lot of cases creates centralization, but also it creates single points of failure. And that's pretty significant, especially if we're talking about a protocol which tries to be as decentralized as possible. And so how it looks like on current infrastructure. Current infrastructure has in its heart a validator client, which is basically just a piece of code which coordinates the execution of duties for the validators. It can hold many validator keys, and of course that validator client is connected to a beacon node, which is the gateway to the actual beacon chain. That validator client is very important because all of the responsibilities for actually getting rewards, working correctly, is up to that piece of software. And because of slashing conditions, that piece of software has to be run in a single instance, no more than a single instance, and that causes a lot of issues, a lot of challenges. It actually goes against a lot of what we've learned in software development the past 30 years, where we try to create robustness, we try to decentralize our different system components, But with this, because of slashing conditions, we can't really do that, or else we're risking getting slashed. There are ways to maybe improve it slightly, but overall it's pretty fixed. And it creates a lot of do's and don'ts in terms of infrastructure development. So of course, don't run a validator in more than one instance, or most probably you'll get slashed. Most of the slashing we saw in the past 6 to 8 months were actually accidental slashing. They weren't even malicious slashing. They were simply errors somebody did, mostly running two validators, two validator keys simultaneously, or forgetting about their slashing data and so on. And so those are things that are very, very dangerous. The validator key must persist and back up all of the slashing data, which is basically the only thing that protects you from getting slashed. And of course, the keys need to be online 24/7 all the time. Those are kind of course, it's a short list of do's and don'ts, but in my opinion, it really goes against everything we've learned in software development the past 30 years, especially trying to build something more robust. There's particular cases of slashing, recent slashing, which were caused by somebody trying to build a more quote-unquote robust system by having maybe redundancy validator client running in the background, or maybe dormant in the background but accidentally got online, and so on and so forth. And so that's really, really tricky. And if that's coupled with what we're seeing in the future of staking, more services, and so on, in my opinion, there's a lot we need to do and think about for this ecosystem to actually be secure and actually be decentralized at its core. And so what is SSV? How it looks like compared to this, right? So this is SSV. On the left-hand side, we still have those validator clients, validator keys, but now they're actually getting generated into shares, secure shares, and those shares are assigned to independent trustless operators. Those operators can be completely different entities, completely different geolocations, controlled by completely different people. And the way they work is they coordinate between themselves with a consensus layer, and they use threshold signatures to achieve a valid signature and broadcast it to the Bitcoin node, and of course get rewards instead. And the cool thing is actually they're fault tolerant. Fault tolerant means that if one of those operators gets, for example, gets offline, gets hacked, and so on, the rest can continue their work, continue operating the validator in a secure way. And so, again, this is a short list of the benefits of SSV, and it's pretty significant. First of all, the actual validator key doesn't have to be online anymore. It can be in cold storage. That's a big improvement. The shares themselves need to be online, but they are distributed between, again, independent operators, trustless operators, and so on and so forth. And in order to actually make a malicious attack, you'll have to compromise not one, but at least the majority of them, which is pretty significant. Threshold signatures are used for security, of course. There's no more single point of failure. If we go back to the scheme, there's no single point where if you attack it, you cause the system to get slashed or even go offline, which is pretty significant. We use fault tolerant, because they're coordinated between themselves using a consensus layer, it's fault tolerant, which is a very robust way of saying the infrastructure can maintain itself even if it's under attack. And of course, because SSV is built as a network, it's actually ready to go infrastructure. So for future services trying to build staking flavors, quote unquote, they can simply use SSV. They don't need to rebuild and reinvent the wheel, and they can use a good infrastructure, a robust infrastructure to do so. And of course, current services can fairly quickly integrate and even switch over to SSV because it really focuses on the validator level, on the lowest infrastructural level. And so the rest of the staking service can maintain its own operations, and only the infrastructure really changes. And that's pretty cool. And so that's SSV, the tech. But how it actually works in real life is even cooler. So if you are a staker and you have 32 ETH and you want to use SSV instead of running something on your own or maybe use some third party, you can do so by simply going to a web app, selecting your favorite operators, and it can be a bunch of them. We actually, in order to be fault tolerant, you can select 3f plus 1 operators. So if f equals 1, you can select 4 operators. If f equals 2, you can select 7, and so on and so forth. The bigger the number of operators, of course, the more robust it is. And you simply distribute the secure shares, which can be generated offline in any computer you want. And from that moment on, the operators coordinate between themselves and actually start attesting, start executing duties for that particular validator. You don't have to run anything on your own, but you still have the confidence that they are decentralized. The keys, the actual validator keys, are offline. And because we're using fault tolerance, because we're distributing the infrastructure, performance is expected to actually be better. And so in private testing we actually got to a point where we run in 100% attestation rate, 100% effectiveness. And of course that's still in testing, but in general the objective is to actually have a better performance because of the redundancy built into the SSV protocol, which is pretty awesome. This whole thing is tied up with a DAO. Oh, sorry, before that. So that was the actual staker, the one who's holding the 32 ETH validator. The operators, on the other hand, are the ones running an SSV node, which is actually pretty lightweight. It's maybe a bit more resource intensive than a validator client. They get themselves exposure to a much larger audience of stakers because whenever they get online and register as an operator, anyone can choose them. And so the bigger SSV network becomes, the more people there are to choose that particular operator. And of course, every single validator has multiple operators which work for it. And so that's pretty cool. And I think the most important thing is the operational cost and risk for each of the operators. The biggest factor by far for any operator, by far, more than development time and resources, more than cloud cost and so on, is the reputation, and as a derivative, if they get slashed, what happens? That's the biggest, the most intensive operational cost they have. And we saw that, unfortunately, in the past few months. If they work in an SSV environment, they work as a committee, and of course, the operational risk gets reduced significantly. Because if they make, by mistake, some issue, for example, they're running 2 instances of the same SSV, and so on and so forth, then nothing really happens. Because they work as a committee, they need to threshold signature, they need to coordinate between themselves via consensus protocol. And so the level of guarantee they have is much higher. And of course, that results in lower cost. And I'll even go as far as to say that stuff like downtime for maintenance is actually possible. So imagine if you have 10 operators on a validator, one of those operators can say, tomorrow at 3 p.m., I'm going down for 30 minutes for maintenance, and nothing happens. The world continues, the validator continues to get rewards, and so on. And our approach is really a free market approach, where each one of those operators can set their own fees. And so the best operators with the higher uptimes and so on can charge more. And so I think from an operator's point of view, that's a pretty sweet deal, specifically on the operational risk. And this whole thing is tied down with a DAO. The DAO is really responsible on a few things. One is actually maintaining a curated list of operators. So the idea here is to have the best operators, the verified operators, gets batched into a list. And that list is used by users to actually select which operators they want to work with. And so you can imagine the best operators getting on that list, getting through a thorough framework of reference and review. And that's actually worked pretty well in protocols like Aave and so on, Lido. And so you'll get the best operators, and you can choose from them. The protocol, of course, is controlling the protocol and network governance. And the last thing, which is probably one of the most challenging things, is how do you continue momentum in terms of development and guarantee the advancements of the protocol. And so the DAO is also responsible for grants and so on. And one of the things I'm most proud of is all of those things sounds amazing, but is it actually here to work and operate it? So I'm very happy to say that the first public testnet for SSV, which is actually the second testnet for SSV, is actually really, really close. So in a few weeks, we'll have everything I've just described, fully operational, working for both operators and validators. You can go on a web app and select operators and see your validator just run. Operators can, on the one hand, get selected, but also run validators. And it will all be functional on the operator chain. And that's a pretty major milestone. And so hopefully you guys will get a chance to check it out. And thank you. I think we have a few minutes for questions if we have any. Yeah.
Wait.
Maybe you have, yeah.
Hey, you mentioned in the beginning of the presentation that the current setup is where multiple validating keys run on one client.
Yeah.
Does that mean that they're running on one instance? Like there's like 10 people who have their own key and they use like one instance of a process that's running?
Yeah, so depending on your setup, if you're a private person, you'll have for at least a validator client running, and then the number of validators you have run on top of it. If you're a very big service, you might batch them up, but still you have a unique validator key set attached to a single validator client. You cannot run them in parallel, for example. And so the single point of failure is always that validator client because it has to have a very defined, unique set of validator keys.
Okay. And then could you guys go into detail on like why it's like kind of this like batching? Why don't individual keys just run their own validating nodes as well?
Why we have to run one validator, a unique validator key on a validator?
No, why don't people why is it batched?
Oh, the batching is just because the validator clients have some capacity. So, they can't run 100,000 validators. And so let's say your validator client runs 1,000 and you have 2,000 validators, then you'll simply run 2 of them. That's mostly the case.
Okay, yeah, thanks.
I think we had a question there.
How does proposing work? Like, how do they coordinate for proposing a block when needed?
So there's the short answer and the long answer. So the short answer is it's pretty simple. You simply have one of the committees suggesting what the next block is. Each one of the committee members, the operators in the committee, validate it locally, so it's not slashable, it's a valid block, and so on and so forth. And if they all agree, they simply sign it. So that's the short answer. The longer answer is, with MEV in place, it actually becomes much more complicated. Well, it's not much more complicated. It only depends if you want to really reduce the ability for a single operator to have a back channel for payments on the MEV, for extracting MEV. That's still in research. It's actually not a SSV specific issue. It's a staking issue. I think that one of the most, let's say, interesting approaches is actually separating block builders and proposers in such a way that the committee, the operators, will choose some block content, but that block content can be produced by somebody else, and they simply have the objective of maximizing the amount of fees they get from that block from the content proposer. And so that's one approach. There are a few others. It's still actually under research. MEV in general for staking is a bit tricky. Yeah. Yeah. Oh, okay. Sorry.
Is time a problem here? So when multiple nodes need to agree about their response first, this takes longer than when a single validator can immediately craft his response.
Yeah, so the protocol currently for staking is, at least for attestations, for example, is to wait until a third of the slot time, which is 4 seconds, and then the aggregator takes whatever it gets up until the 2/3 of the slot, which is 8 seconds, and then broadcasts it to the network. That's well over what the SSV protocol needs. So I'll give you an example. Cosmos, for example, is a BFT protocol. It has around 100 operators or validators in it, and they get to a consensus within 2 seconds. And here we're talking about much lower numbers because you don't really need 100. So I don't see that as a problem. We ran a testnet. Of course, it's a small scale testnet, but we didn't have a problem with that. Yeah, I mean, 4 seconds is a long time.
Thanks.
Anybody for a last question?
We had one here. Oh, it's the same question? Cool. Thank you, everyone.
Okay.